Alrighty. Remember yesterday we were talking about two body problems, and we looked at two different methods that we could employ or use to solve these two body problems. And you're only going to need to know or be able to use basically one of those methods, and you on the quiz and the exam. So if you're more comfortable with method 1, then that's great. If you're more comfortable with method 2, then that's also great. Remember, method 1 involves a system analysis, and we use that to determine the acceleration. The first step is considering that the two objects that are part of the two-body problem are actually just one moving object, and we draw a free body diagram of that one single moving object. The mass we get from the sum of the individual objects, just combining them together and assuming they're one, and then we can solve for acceleration. Then we do an individual body analysis after we've done this and solved for acceleration. And remember, this is where we take one of the two objects that are part of the two-body problem and we isolate one object. And we use that isolated object in order to determine the force, usually the contact force, or it could be the tension force, or the applied force, between the two objects. So there's going to be two unknowns for all of these problems. The second method is when we just do two individual body analyses, and we draw free body diagrams for each of them, and then we have two equations and two unknowns. And remember, we basically substitute parts of one set of equations in for another, and then we solve for our acceleration and our contact or applied or tension force. So whichever way you feel more comfortable with, that's great. As long you do have to use this method, one of these two methods, while you're solving these problems. You can't just wing it. So let's go over the homework problems. We'll do number 1 first here. I assume everyone is, from what I've seen, well, the people who do their homework, you all are going to more likely do the first method, so I'm not going to waste my time doing both method 1 and method 2. If you are more comfortable with method 2 and you want me to solve the problem using method 2, then you need to text or WhatsApp me or Google Classroom comment me, so I know that. So I'm aware that I need to go back and do this in method 2. But for now, I'll just be using method 1 for both of them. Okay, so this problem was basically very much the same problem that one of the practice problems that we did, just with different values. So we have a big truck here on the right pulling a little car on the highway, and we know the mass of the big truck and we know the mass of the little car, and we know that the truck is moving forward with a force of 1.75 times 10 to the 4 newtons. And I tell you to use method 1 or 2 if you're more comfortable with that one, to determine the acceleration of the car and the force at which the truck pulls upon the car. And we are going to ignore air resistance forces. Okay, so first step, we're going to use method 1, like I said. And the first step of method 1, remember, is the system analysis. And we'll use this to solve for acceleration. Okay, so first we're going to draw this above as one single free body diagram. So I'm going to imagine there are no barriers between the two objects. And then I'm going to fill in all of the forces that I know of. All right. So first, of course, we have the normal force of gravity. But I also have the applied force of the truck's engine, which is 1.75 times 10 to the 4 newtons. Just for kicks, I'm going to solve for force of gravity and normal force here, because technically a free body diagram should have all of the values. So force of gravity equals mass times gravitational strength. The mass I'm going to get from adding these two together, right? Because we're assuming that this is one body now. And when I add them together, I get 5.8 times 10 to the 3 multiplied by force of gravity here. All right. When I plug that in, I get a force of gravity equal to 5, how many significant figures? 2 significant figures, 5.7 times 10 to the 1, 2, 3, 4 newtons. All right, and so I'm going to erase all my work here and just move this guy up. There we go. All right, and I know that because the truck is not moving, move this up, oops. Because the truck is not moving up or down, right, we know that these forces are balanced. So I can say that the force of gravity is the same as the normal force, or the force of gravity and the normal force are the same. So I've solved for that one. All right. Okay. Now that my free body diagram is complete, I can move on to solve for acceleration. Remember that F net in this situation is, we're not looking at this one or this one because they're balanced. So the net force on this single object is equal to the applied force here, right? So we know the applied force, therefore we know the net force. We know both of those. We also know that the net force is equal to mass times acceleration, Newton's second law. So we can take F_, put it in there, and we get applied force equals mass times acceleration. Now all we need to do, since I know the applied force, I know the mass, I just used it to solve for force of gravity, all I have to do is rearrange for A by dividing both sides by m, and I get acceleration equals applied force divided by mass. Then I just need to solve. So when I plug all of that in, I get an acceleration equal to 3.02. But we only have 2 significant figures here, so actually it will just be 3.0 again, and no times 10, sorry. And this is newtons per kilogram, which is also meters per second squared. All right, we can say either way. All right, there we go. We have solved for our acceleration using our system analysis section part of method 1. Now we're going to take that information that we just determined, and we're going to do our individual body analysis. Okay, so I am going to choose one of these 2 objects, and this time I'm going to choose the car. All right, I'm going to choose the car, and I'm going to do my individual body analysis on the car. So when I do that, I'm ignoring the truck, and I'm just drawing a free body diagram of the car. Okay, so let's write all the forces. Force, normal force, gravitational force. We're going to solve for gravitational force. Remember the mass of the car. What was the mass of the car? 2.10 times 10 to the 3 kilograms. So we have 2.10 times 10 to the 3 kilograms times 9.8 newtons per kilogram. If we plug that in, we get 2.06 times 10 to the 4 newtons, right? 1, 2, 3, 4. Yep. Okay, so we have solved for gravitational force, which is the same as our normal force. I just wanted to do that because that is technically how we complete a free body diagram, right? We have to fill in every magnitude that we have. Oops. There we go. Okay. We also have one more force. So remember, we're drawing the car right now. And we're not going to write the applied force on the car, but we are going to look at the contact force between the truck and the car. This contact force is what we are going to need to solve for. This is basically our goal, is figuring out what is that contact force, what is the force that exists between the car and the truck. All right. So this part is a little easier. Remember, let's write our stuff out here. Okay, so we know the acceleration. We just solved for it. We know the mass of the car is kilograms. And we want to know the contact force. Okay, well, we know that the net force acting on the car is the same as the contact force because we're not going to look at our vertical forces. They're balanced, so we don't care about them. So that means that the net force is the only force acting on the car is the contact force. So since net force equals contact force, and since net force equals mass times acceleration, we can say that the contact force is equal to mass times acceleration. And I don't even have to rearrange anything. I just plug everything in and I'll be able to solve here. So we have our mass. And we're going to multiply that by our acceleration. And when we do that, we get a contact force equal to 6.3 times 10 to the 3 newtons. All right, so on some of the problems you're going to see today in your assignment, I'm going to ask you to explain what you've found. So let's write a sentence about what we've found, okay? So in part 1, in the first step of method 1, we found that the acceleration equaled Okay, and we found that our contact force was equal to 6.3 times 10 to the 3 newtons. What does this mean? So, remember our initial problem that we were looking at was that we have a car being towed by a truck, right? So, what you could say something like this. The truck and the car are accelerating at 3.0 meters per second squared, and the force that exists between them is 6.3 times 10 to the 3 newtons. So I'm going to ask you to write a sentence about the things that you found in the homework today. So be sure the reason I'm doing that is not just because I like to read what you write, but it's because I want you to understand what these two things you're actually solving for, because it's very easy after doing all of this work to be like, okay, well, I found this and this, and forget what the point was, what those numbers actually mean. All right, let's look at number 2 real quick. All right, so here we have a 7.5 kilogram box, and it's attached to a 3.0 kilogram box by rope 1. Okay, this should say rope 1 also. No one asked me any questions about that, so anyway. All right, so we have this 7.5 kilogram box and a 3.0 kilogram box, and the 7.5 kilogram box is pulled by the rope with a force of 25 newtons. 25.0 newtons. All right, so let's draw a diagram. What does this look like? All right, so we're going to draw our two boxes now. Rather than two objects, we're going to draw them as one, which I've done here. We're going to solve for our force of gravity and therefore our normal force. The force of gravity will be equal to the mass of both boxes, so 3 plus 7.5 will give us 10.5 kilograms. Multiply that by 9.8 newtons per kilogram, right? This is mass times gravity. And when we plug that in, we get a gravitational force of 103 newtons. That's going to be the same as our normal force. Okay, so solved for that. But also, we have an applied force this way on the box, and that is equal to 25.0 newtons. Okay, so now we have everything drawn. We can solve for our acceleration, since that's the point of the system analysis portion of method 1. Okay, so we know that the net force is going to be equal to the applied force because there's no vertical motion. We know that the net force also equals mass times acceleration. So I can say that the applied force on both objects equals mass times acceleration. Divide both sides by m, and I get that acceleration equals the applied force divided by the mass. If I plug everything in, I get 25.0 newtons is the applied force, divided by 10.5 kilograms, right? Because this little box is 3 kilograms and this is 7.5 kilograms. And I plug that into my calculator, and I find that my acceleration equals 3 significant figures, 38 meters per second squared. All right, so they're moving at an acceleration of 2.38 meters per second squared. Now that I have that, I can do my individual body diagram. And I am just going to arbitrarily choose to do this on the 3 kilogram box. I have a normal force. I have a force of gravity equal to 3 kilograms times 9.8 newtons per kilogram, mass times gravity. That is 29, gives us a gravitational force of 29.4 newtons, same as the normal force because there's no vertical motion. All right, I also have tension force in rope 1, right? There's tension force, and it's actually being pulled to the right. So this would be tension force from rope 1. What I'm going to do is write all my things out. I know that the net force on this first box is going to be equal to the tension force, right? I know that the net force is also equal to mass times acceleration. All right, so I can say that my tension force that exists in the rope is going to be equal to mass times acceleration. Well, I already know my mass is 3 kilograms. I know my acceleration is 2.38 meters per second squared. And I want to know the tension force. So I don't have to rearrange, I just have to plug everything in. I get tension force equals 3 kilograms times 2.38 meters per second squared. This gives me a total tension force of 7.14, but did I give you how much? Okay, I said 3.00, right? Yeah, I wrote this wrong. 3.00, that's important because we need to keep track of our significant figures. 3.00 kilograms. All right, so our answer should have 3 three significant figures, and our tension force is 7.14 newtons that exists in rope 1. Remember, that's what we were looking for. All right, so let's write this in a sentence. How would I explain the information that I've discovered? Woo, there we go. A 3.00 kilogram box is attached to a 7.5 kilogram box by rope 1. The 7.5 kilogram box is being pulled by a second rope with a force of 25 newtons. The two boxes accelerate at 2.38 meters per second squared, and there is 7.14 newtons of tension force in the rope connecting the boxes. There we go. That shows me that you understand what you're doing. You did it appropriately. You got the correct answer, etc., etc. Okay, so all these things that we've been doing so far, this example, for example, I tell you to assume friction is negligible. Well, if we're pulling these boxes on a surface, is friction negligible? No. We cannot just ignore the friction of a surface because every single surface has friction. So what we're going to look at next is some problems involving where we don't neglect friction. And this is more like what you're going to see on the quiz, these types of problems, because in the real world, friction is not negligible, right? We can't just pretend friction doesn't exist when we're in this situation. We're pushing two boxes across the floor. The floor has friction, right? Okay, so let's just do this example problem here. This is almost exactly the same as the problem we started with yesterday, but this time we're not going to ignore friction. This time we are going to take friction into consideration. We're not going to do anything differently. We're still going to use method 1, and we're still going to do our system analysis first, and our individual body analysis second. So let's look and see what we have. We have a 5 kilogram box, and I already have this drawn over here, so I'm just going to say this is the 5 kilogram box. And we have a 10 kilogram box, and they are touching each other. A 45 Newton horizontal force is applied here by the hand. 45.0 Newton force is applied to the 5 kilogram box in order to accelerate both boxes across the floor. But now we have the coefficient of kinetic friction, or just friction. Remember, the mu is equal to 0.200. Remember, that's the coefficient of friction. It doesn't have any units, it's just a constant. Okay, so when the question says there's a kinetic, or there's a coefficient of friction, that means that we have to take friction into consideration, okay? All right, so we're going to do the same thing. We're going to start by drawing our free body diagram. And nothing has changed with the method or what we're doing. We're going to do our normal and our gravitational. And now it's going to be very important that we actually are giving these two values, because we're going to need to use the normal force in order to solve for the frictional force, which we'll get to in a second. So let's look at this. We have a 5 kilogram box and a 10 kilogram box. We're combining them, so that means 5 and 10 kilograms. This whole thing equals 15 kilograms. So we have times our gravity. Mass is 15 kilograms times 9.8 newtons per kilogram. This gives us a gravitational force, 15 times 9.8, of 147 newtons. Gonna erase all that there. All right. Okay, and this is going to be the same as our normal force because we don't have any vertical movement occurring, so those forces are balanced. All right, we're going to also, whoopsies, wrong. There we go. We're going to also draw our applied force because we were given that one. We know that the applied force, remember, is 45 newtons. The hand is pushing over here technically, but when we draw the free body diagram, we have to draw it like this. All right, we have one more force, and that, we don't need to erase that. That is the friction force, which opposes the friction. It opposes the applied force. We do not know what the friction force is. So before we can do anything, we have to figure out what is our friction force, because we have to complete our free body diagram. But also, think about what our net force is going to be. Our net force is going to be our applied force. We have to look at these two forces, right? So unless they're balanced, but they're not, because we say that the boxes are moving, they can't be balanced. So it's going to be our applied force minus our friction force. So we need to know what our friction force is so that we can solve for our net force and then eventually our acceleration. Remember, the equation for solving for friction is equal to the coefficient of friction times the normal force. So conveniently, we don't have to do a lot because we were given the coefficient of friction. We just solved for the normal force. So all we have to do here is plug in our coefficient of friction, which is 2.00, and multiply that by our normal force, which is 147 newtons. And we get 147, a friction force equal to 29.4 newtons. Cool. So, we're good. That was super easy. Write this in here. 29.4 newtons. Okay. So, now that we've solved for that, we can go ahead and erase all of this. We can solve for our net force. Remember, our net force is going to be our applied force. Also, you can be checking yourself. When you solve for the friction force here, think about, does it make sense? The box is accelerating, and I think it even said, yeah, it's this is in order to accelerate both boxes across the floor. So this force that the hand is pushing, this applied force of 45 newtons, is able to accel the box across the floor. So we want to make sure that our friction force is smaller than our applied force in order to ensure that we have an acceleration in the rightward direction, right? Because when we balance these out, we're going to have 45 newtons minus 29.4 newtons, and this is to the right, and this is to the left. So we get 45 minus 29.4. This gives us a net force equal to 15.6 newtons, and that will be to the right, which is great because that is the direction that the applied force is being applied. Okay, so now we know our net force, we know our mass. We can write all of our stuff here. We have our knowns, which we know our net force is equal to 15.6 newtons. We also know our mass, right? We have the 5 kilograms and the 10 kilograms, so we have 15 kilograms. We are looking for acceleration, and our equation is force, or net force, equals mass times acceleration. Divide both sides by mass. Acceleration equals net force divided by mass. If I plug that in, I get acceleration equals 15.6 newtons divided by 15 kilograms. This gives us an acceleration of 1.04 meters per second squared. All right. There is our first step. So we only have found our acceleration so far. Now, the second part of the problem wants us to determine the contact force that exists here between the two boxes. So let's do that. I'm going to do our step 2, which is our individual body diagram or analysis. I am going to choose the 10 kilogram mass, my normal force, my force of gravity. Force of gravity is going to be equal to 10 kilograms times 9.8 kilograms, which is 98 newtons. Those two are equal. Okay, what other forces exist on the second box, the 10 kilogram box here? We have the contact force in this direction between the little box and the big box, and we have the force of friction in this direction between the floor and that box. All right, so let's write everything we know, what we don't know, and the equations. We know that our net force is going to be equal to these two forces, right? We have to subtract those in order to determine what is the net force. So this will be the contact force minus the friction force. We also know that the net force is equal to mass times acceleration, right? Okay, so we see a problem here. We can't have two unknowns. We can't not know our contact, and we can't not know our friction. The friction is not going to be the same for this box as it was for both the boxes together when we did the system analysis. So what we need to do first is actually solve for our force of friction. So then we can plug it in here, over here. And, oh, sorry, that's the contact. Wrong one. Our force of friction over here. And then we can solve for our contact force. All right, so our force of friction, remember, is mu times the normal force. We know that mu is not going to change for this surface. It's a constant for that surface. And we just solved that, or found that the normal force was 98 newtons. So if we plug this into the calculator, we get a force of friction equal to 19.6 newtons. All right, so I'll write that here, 19.6 newtons. Okay, well, now I know that my F net is equal to my contact force, my contact force minus the friction force. I also know that the net force is equal to mass times acceleration. What I can do is plug this in here, and I get contact minus friction equals mass times acceleration. What I need to do, though, is rearrange this so I'm just solving for my contact force, because that's what the problem asks for. So I'm going to add my friction force to both sides. So I cancel it on this side, and I get a final equation of my contact force equaling mass times acceleration plus my friction force. All right, let's write down everything we know. We just solved for friction force, actually. So we know that it's 19.6 newtons. We know the mass of this one box is 10 kilograms. We solved for the acceleration back here, remember, in step 1. So we have 1.04 meters per second squared. What we're looking for is the contact force between the two boxes. All right, so we have this. Let's go over here. Use a different color. We have mass, we have acceleration, we have friction force. Now we can plug everything in and we can solve. So my contact force equals my mass of 10 kilograms times my acceleration that I solved for earlier plus 19.6 newtons. When I plug all of this in, I get a contact force equal to 30 newtons. So, if I wanted you to write this, what you've discovered, in sentence form, what you would say is that there are two boxes. The first box with 5 kilograms is pushing against the second box of 10 kilograms, or that has 10 kilograms of mass. The friction force between these two boxes is 30 newtons. Sorry, not the friction force, the contact force between the two boxes is 30 newtons. And the boxes are being pushed with a force that causes an acceleration of 1.04 meters per second squared. Okay, so these are more similar to the kinds of problems. So really all we're adding in here is this one extra little step to solve for friction force. But other than that, I guess the equation that you need to do is a little different, or you need to use is a little different also. Rather than just saying friction or net force equals the contact force, we also have to take into consideration friction here now. So our final equation will look a little different. We'll have this friction force included there. Okay, so what you're going to do for the rest of the period is work on the 2.3F practice problems, and those will be due tomorrow at the start of class. The late policy won't apply to these again because I'm going to go over them. So you need to have these done before 9:53 tomorrow morning. Please let me know if you need help or have any questions, or if you want me to go over how to do these in method 2. You need to tell me that like right after class if you want me to do that, so that I have time today to do that for you. So please let me know if you would prefer a little method 2 mixed in there as well, or if everyone is kind of just okay with doing method 1. I introduced them both to you so that you could make that decision on your own, I think. And also, well, you're not enough of you are doing the homework for me to tell really if anyone wants to do method 2 more than method 1, but the one person that did do the homework did method 1, so that's why I'm doing it like this, because I think it's a little easier as well. Please let me know if you have any questions. Thank you.